Hello and welcome to the LINBIT community meeting. My name is Michael, and if this is your first time with us, this is an open community meeting where we open the meeting to the public, where you'll receive updates about the latest LINBIT software developments and have the opportunity to get answers to any of your pressing questions that you may have. At the end of each section, we will have a quick Q&A session, so if you have any questions, please send those in. You can ask in the Zoom chat, YouTube live chat, or use voice in Zoom. If you want to do that last one, write your question in the Zoom chat and label it as a voice question. So let's get this ball rolling with some developer spotlights to find out what about the work that's being done here at LINBIT. So Philip is joining us to talk about restoring quorum. And this is going to be interesting because a lot of media these days, they like to be using degrading humor. And I prefer restorative humor. So Philip joining us to talk about restoring quorum after reboot of a degraded 3-node cluster is something I'm definitely interested in. So Philip, the floor is yours.
Thank you, Michael. Okay, so I will share an illustration, and this always takes me a second to find the right window. And here we go. And I assume the screen sharing is coming through. Yes.
It is.
Yeah, it's good.
Okay. So I start with a 3-node cluster, and it has one diskless node. And I labeled my nodes. This time I labeled them I1, I2, I3. And if one of the 2 nodes with disks go away, the 2 remaining nodes keep quorum. And even if the diskless node goes away, the last one will still keep quorum if it was primary at that moment. And why is that? Because it can be sure that the away nodes are not able to gain quorum. And then let's assume this node reboots. And we can then have a look at the other partition, so the I2 and I3 node, and we will notice that they don't gain quorum, and that's good. So we don't have a diverging data set. And then finally, we start up that I1 node again, and we will see that it restores quorum. And this is what this feature is about. It's about that a single surviving node, if it has quorum, can be gracefully rebooted or hard rebooted, and it will regain quorum after getting rebooted. Okay, so far to the theory part of it. Now let's turn to the hands-on part. And now I need to find the right window again. And it's this one. Okay, screen sharing is here. So now the same thing, but with dbd live. So I have the I1 node in the upper right corner. It's primary, and I can write to it, no errors. So this node has quorum. I have 2 healthy nodes. The I3 is diskless, and the I2 has a backing disk, just as I showed before. And these are 3 virtual machines. So I think I started with losing this I2 node. So I will do that with vir. Okay, let's write again. Status, we see we lost this I2 node. It will not react to my input. And I think the next step was that we also lose the I3 node. So let's do that. And it's gone. And here it still doesn't complain that it has lost quorum. So let's try it out. Yes, we can write. So this node has quorum. The other 2 don't have quorum. And now the idea was I want to demonstrate that I can reboot this I1 and then restore quorum when it comes back online. I will not reboot the entire virtual machine. I will just use dvd adm down. My resource is called R0. So now the machine goes down. For this demonstration, I just take the resource down. Now let's have a peek at the other cluster partition. So let's wake them up. Let's resume I2, resume I3. In the meantime, my SSH gave up. So let's re-log in. Status. It says no quorum. And so point proven, this partition doesn't have quorum. You might notice it marked its own disk as outdated. So how comes that? The reason for that is that this diskless, the diskless saw that I1 created a new data generation. So it has this newer, it knows that a newer data generation exists. And when it now reestablished a connection with I2, it told it, hey guy, you're outdated. Your data is consistent, but you're no longer the latest one. So therefore, this one knows that. So now let's suspend these two guys again. And now let's assume I1 is finally coming up again. Okay, let's look at the status. And we see, surprisingly, it has quorum. So it doesn't complain about no quorum. And we can look at the kernel messages, going back a little bit. And here, this is the new message you can find in the log file. Restored quorum from before reboot. So that's a new feature of DVD 9.1.18, and it's also in DVD 9.2.7. This was not existing before. Okay, that was my little demonstration here. I'm ready to receive questions, or if you need a second to think about your question, I will stay here for the whole meeting. Thank you. Oh, Michael, there's something wrong with your audio.
Thank you, Philip, for that. We don't have any questions just yet, but we will let you know if they come in during the stream. So next up, let's talk about something that is going to be used. Wow. Renee is joining us to talk about some updates for the LINSTOR driver. But what do you get when you add a Cumulus cloud to a Nimbus cloud? That's right, a cloud stack. So joining us right now is Renee to talk about the recent updates for the driver for LINSTOR in Cloudstack.
Hey, hello. Oh, a bit dark here. Sorry. Yeah, recent updates. More of a talk here. What we have is in the next version, we will have support for the HA feature of Cloudstack, which will be not in the next version yet. I mean, not in the 4.19, which will just get released. It will be in the version 4.20. And what this means is Cloudstack right now had an HA feature, but this was limited to the NFS storage. So if you wanted to use that, you had to use at least one primary NFS storage. Yeah, and now you can use the LINSTOR storage for that. So you don't have to additionally add an NFS storage. It will just work then with the LINSTOR driver. Apart from that, we added, what was the other thing? I'm working right now, or in the working is the possibility to do snapshots on virtual machines. This will be also part of 420. And is not right now, is not in the 419 release. So yeah, as I said, this will be possible then to use LINSTOR for M snapshots, which is currently not possible. And other things we had now is oh, sorry, I have bit lost right now.
Happens to the best of us.
Yeah, not outdated. Oh man, where are my notes? Sorry, give me a second. Oh man.
Renee, I don't want to derail you, but I did have a question that maybe will jog your memory while you're.
Yeah.
So with the primary storage for Cloudstack being on LINSTOR, how do the ISOs and templates get delivered to each of the hosts? Like, is it a diskless connection that they all make, or are those ISOs that are stored in primary storage or secondary storage on LINSTOR? Are they? Yeah, how does that work? Are they replicated to all the hosts, or?
No, Cloudstack works like, so you have the secondary storage and all non-virtual machine templates and all that stuff, images, ISOs are stored on the secondary storage. And the first time you use such an image, for, let's say, you make an instance of a template, the template image gets copied to your primary storage on which the instance is running. And yeah, this is done also for the LINSTOR driver. So it will be copied from the secondary storage into an LINSTOR resource. And from there, it will get cloned. So as soon as you, so once this first image, this base image is copied, we will do a clone operation of that for any additional instance. And this means it will be as fast as the backend storage can do that. So if you have thin storage on, or even with fixed storage on LVM, we do a bit of trick. So I mean, usually we don't support snapshots on fixed storage, but for Cloudstack we have, or for cloning, we have an exception because we know we will delete the snapshot right after the cloning is done. So there will be no performance issues with LVM. But for that, we will just make a snapshot and copy from there, or use, I think for Fin, we even just used the snapshot on LVM, and on ZFS, we do a send and receive because we don't want to have this parent-child relationship in ZFS, which would then render deleting clones very hard. I mean, it would work for Cloudstack, but we don't want it for the usual for the common case. And thanks, that helped me. So now I'm back on track. What else we added for the upcoming 419, which should be released in the next few weeks, I guess. I'm a bit out of the loop. They still had problems, Cloudstack, with the 419 release. But there will be in backup snapshots to secondary storage. So currently, or before that, when you did a snapshot, it was just kept on the primary storage. So it was just a LINSTOR snapshot in the end. But what I found out after working with the driver more and more is that the usual behavior is that if you do a snapshot from a volume, it will get copied to the secondary storage. And that's what's happening now by default. There is an option, you can disable this if you want the old behavior, but we will now do it like a Cloudstack user would assume it should work. That's one thing. Then there were additions to this aux property name in the resource definitions, which helps you to keep track on which LINSTOR resource is what Cloudstack resource. And now there is also template names included in that. That's all in the 4.19 release. And for 4.20, as I said, the VM snapshots will be part of it. There I have a branch which is mostly done. Still have one bug to fix, which I not have much time right now to work on, but before 9.20 will be out, this will be done. Yeah, and yeah, a new thing which we have for 20, which I will be working next is encryption support for Cloudstack. So Cloudstack has a native encryption setting for volumes or for disk offerings, and we will try, or we will support it directly for LINSTOR. So if you set that option in Cloudstack, the volumes will be looks encrypted in LINSTOR. Yeah, and that's what's new in Cloudstack.
Nice. So we don't have any questions after Matt's, so we're going to move on to the next one with Gabor. So what do you get for the person who has everything? Storage. But what do you get for the company that has a ton of data to manage? That's LINSTOR. And that is why Gabor is joining us now to talk about the new features in LINSTOR.
Thank you. At least I will try to show you, to demonstrate you a new feature, what we call mixed storage pool. And I hope you can see my screen right now. So what I have prepared here is not much. It's a relatively small and freshly set up LINSTOR cluster. We have, as you can see, 2 nodes, only 1 storage pool each, but the fun part is that they have different types. No resource grouper, sorry. So nothing special set up here. On the right side, we see on the Bravo node an LSBLK output, and basically the same for Charlie, just to see how things evolve while we play with the LINSTOR commands. So for the starting, let's just spawn 2 very simple resources. As I said, I don't have a special resource group, so I have to use the default one. Let's make it pretty small because it doesn't really matter. For now, I will just spawn it on 1 node, and I want to make sure that it lands actually on the node I want it to, which is in this case Bravo. And as you can see, the volume got created, the LVM volume, and the DABD got created on top of it. So here comes the second volume, second resource, sorry. And it's on Charlie because, well, as said, ZFS or LVM is a provider, and these are the only option for now. So what does it mean? Why was it a problem for LINSTOR to mix storage pool types for now? I don't want to go too much into details, but as you can see, in both cases, I created 100 megabyte resource, but I got slightly differently sized DABD devices out of it. The very brief explanation of it is different extent sizes. So that's also one criteria that LINSTOR uses to determine if we have a mixed storage pool setup. So that means that you do not need to mix LVM with ZFS. You can also achieve a mixed storage pool setup by only using LVM, for example, if two storage pools have different extent sizes. And you can literally define your own extent size during, I guess it's the volume group creation step on LVM. So as soon as Linster detects different extent sizes, it considers it as a mixed storage pool setup. And from there on, we can continue as follows. So as I said, this is the problem. DABD has a slightly smaller size on these two. And if you wanted to, even if not using the autoplacer, but just plainly create the resource one, which is already deployed in Bravo, also on Charlie, you will get the error that it's not possible. At least it was not possible for now, because this second part is new. You can enable mixed storage pools using this property. And for now, I will set it on controller level just so that all resources are affected from it. But of course, you can also set it on resource definition or resource group level, wherever it should make sense. Repeating the very same command, it connected. We also saw the brief resync, and we also see the device sizes match up. So this is how it works. And just for completeness sake, if we create a third resource without any limitation, without any restrictions, since I have allowed storage pool mixing on controller level, newly spawned resources are also considered from the autoplacer. So the autoplacer itself also has no problem with mixing the storage pools if the property allows it. As I said, it was relatively brief, and that actually already sums it up. Are there any questions?
Thank you, Gabor. I have 2 questions. Can I?
Sure. Yeah, sure.
Is LVM and LVM clean can also be mixed together?
Yes, actually, I forgot to explain. Linster has 2 criteria. The first criteria for mixed storage pools are different extent sizes, and the second criteria is mixing thin and thick storage pools, regardless of the other type.
That's pretty cool. Should all the old resources be updated before enabling this option, or it will work just out of box?
It works. I mean, the whole problem was literally just the backing device size for the DABD provided. As soon as the backing device size is large enough, so to say, DABD will happily replicate and you don't have any issues.
Got it. Thank you.
Gabor, maybe you need to add that this requires a pretty recent DABD release, right?
Right, that's true. So it requires the just recently released 2.9.2.7 and what was it, 9.1.18?
9.1.18, yes.
Yes, exactly. So there were a few DABD requirements to allow for this mixing to work properly. So that's the reason. And Linster also complains about it. So if you are not sure what the exact versions are, just try it, and Linster refuses if DABD is not recent enough.
Thank you.
Nice. Are there any other questions? Okay. So up next, Maurice will be taking the helm to chart our path through how the LINBIT SDS operator version 2 for Kubernetes looks with the new Helm charts.
Thank you, Michael. Quickly will share my screen. And
It's coming through.
it's coming through. You see the Firefox right now.
Yep.
Yes.
Do you see something else? Okay, just showing up weird for me on Zoom. Okay, so first of all, I want to take a look at some improvements to our documentation we have made. As you probably know, we have the operator version 2, which is a rewrite and improvement of our operator for Linster on Kubernetes. And we do provide a migration path if you're using operator version 1 right now. So we have a complete guide on charts.lin-store.io with all the necessary steps you need to do. Also, perhaps some users just want to migrate away from etcd. This is explained in here. And an automated script which takes a look at the current state of your cluster and tries to convert it to an operator version 2 deployment, and so on. So that's that. Then the already mentioned newest development on the deployment side for operator version 2. Previously, we had this deployment with kubectl where you could deploy the operator directly with kubectl using the built-in customize feature. But a lot of people like to use Helm. And so there is now a Helm chart for that. Instructions are here or in the user's guide. And I will demonstrate this right now, and also then use this to show some new features for monitoring LINBIT SDS. So now we are back at my usual test setup, a 3-node cluster with Kubernetes deployed. I've also deployed the cert manager for certificate management already, and this we will see shortly. And now we will simply install LINBIT SDS. And first we will deploy the LIN-store operator, and I'll add my credentials to pull from drbd.io. And this should quickly start running our operator. And now one big difference between the old deployment of operator version 1 is right now you just installed the operator, but it will not set up or it won't automatically set up the whole LINBIT SDS. For that, there is a separate chart. And let's install that. And now we quickly see a lot of new pods being created. The HA controller, the satellite nodes, the LIN-store controller, and all the CSI components. And so we will just need to give them a bit of time to start up. It will fill in the LIN-store database. You can see the satellites are already running. LIN-store controller needs a bit of time. So we can see it right now working through the initial migration of the database. And when that is finished, our cluster is ready to go. Let's see. Let's try it out if it's already running. Yeah, so the LIN-store controller is up and running, and it should quickly register all the different satellites. And because we haven't configured anything, there are only default storage pools. So what you can do with the new deployment or with this new LINBIT SDS deployment with Helm, there are a lot of different values you can set, but most of them should be self-explanatory or are described in our user's guide. And I want to focus on first setting up TLS, so securing your deployment with encryption, both on the LinStore API side and internally with LinStore. And if you use our Helm chart, there's a simple way to do that. Just set these values here to cert manager. And I've done this in this file. So this we'll use to override. And second of all, we can define storage overrides, and I will set up a storage pool like this. So I simply define an LVM thin pool and tell it which device to use. So now we will upgrade this, and this will first of all, because we specified the cert manager resource, it will create the necessary certificate resources, which will take some time to show all of them. We'll need some reconfiguration on our pods because they now need these TLS secrets configured, and this should not take too long for all of them to start back up again. And then we can check that everything's working again once the LinStore controller started. So now it has started back up again. And now if you ask the LinStore client which controller it uses, you can see it's using HTTPS, so the secure API. And in the node list, you can see that all the satellite connections are also using TLS or SSL connectors. And finally, our storage pools are all configured with this LVM thing. And now the last thing, the chart, or another thing the chart can do is configure your storage classes. And I just have this sample storage class here, which creates just a resource group with, which creates the resource on all three nodes at the same time. And so let's deploy that too. And yeah, so now we have a fully functioning cluster, but we may want to monitor that, so to get reports of any defects. And one popular solution for that in the Kubernetes world especially is Prometheus, and all the stack around that, like Grafana dashboards and alerts and so on. And for that, there is a simple solution also involving Helm. Deploy that. This Prometheus or Prometheus stack, and I'll just deploy that now. And this also takes some time. As you can see here, there's a I've also specified an override file for that, which we will quickly take a look at, because we are actually using LinStore itself to provide the backing for the storage class, or the backing for the Prometheus storage. And so this is this one here. We just specify a volume claim template, and because our storage class is the default one, it will just be picked up. And these values over here are just so that the Prometheus not just monitors its own namespace and the kube system namespace, but actually all namespaces. So we can quickly check that the persistent volume by Prometheus is actually bound. And if we take a look at the LINSTOR side, we can see that it's currently running on node 11 and yeah, just working as one would expect. And now for the integration with LINSTOR or further integration with LINSTOR, you can define the following override for Helm, just enabling monitoring. And if I deploy that too, then we get some additional resources for Prometheus. Namely, there's a pod monitor, which tells it to monitor all satellite nodes, and a service monitor, which tells it to monitor the LINSTOR controller, and some additional rules for alerting. And we will take a look at what all those do one at a time. So first, let's take a look at Prometheus itself to see that it is working. I'll just forward it to a local system. And now I'm in the Prometheus console. And first, let me check that the LINSTOR info. Sometimes I need to reload this to actually complete. Doesn't want to pick it up right now. Why not? DRVD is also not up. Guess I have missed some deployment step.
That's the wonders of live demos.
Yes, exactly. Let me take a look in here. Looks all fine. That also looks good. What else could it be? Now it's, don't know why that took so long. First of all, we can check the DRVD version, which is just a kind of live check for all the different nodes. You can see there are 3 entries for all the different, for the 3 nodes we are running on, and they report the DRVD version as 926, which is as expected. And then we can see the LINSTOR info, which is reported by the LINSTOR controller, and it tells its own version and so on. And can actually see the LINSTOR resource state, which reports the overall state of the resources. And if we need a closer inspection, we can actually query the DRVD resources too. But of course, that is quite nice to explore, but maybe not what one wants to look at every day, or does one or wants to do every day. So we have also a Grafana dashboard, which we can take a look now. And there are the Prometheus operator has a number of built-in dashboards, and we've also added our own LINBIT SDS one, which is also just enabled by this one flag in our Helm chart. And there you can see the overall disk usage in concrete numbers, how many resource definitions, and so on. There are some statistics on writes and reads of volumes, some additional DRBD information, which luckily shows no disconnected resources or something like that. And you can play around with that and just show like the last 5 minutes or so, because we just deployed it. And so that one is nice to look at. And now for the actual alerting, we have the alert manager. Also just forward now. Which looks like this, and right now there is just a watchdog alerts and one regarding etcd, so nothing from the LINBIT SDS side for now. But what we can actually do is, if we list our volumes and jump into this container right here and disconnect that one node. Then in LinStore, it will look like this because the connection is broken between the node 10 and the other ones. And in Alert Manager itself, we should quickly get alerts for the LINBIT SDS namespace and some description of what the actual problem is. In this case, the node 12 is reporting that it can't reach node 10, and you will get multiple alerts in this case. But it would also report stuff like some resources out of sync, or a resync is currently running, but it's not making any progress, and so on. So there are a number of different alerts we've built in that if you use this alert manager from Prometheus, and if you set that up, you will get notified. Like it can do email notification or goes to a Slack channel or something like that. Yeah, so that's basically everything I wanted to show. Are there any questions?
Okay, if there's not any questions right now and you are watching this later on the YouTube, you can feel free to leave a comment and we'll get to you later, or you can contact the LINBIT experts directly at linbit.com. We do have some questions in the Zoom chat for the previous talk for Gabor. So let's hand that over to Andre. So the floor is yours.
Thank you. I just challenging the same question about snapshots. So will it work between the storage pool LVM and LVM thin type?
LVM and LVM thin, no, because simply the reason every resource has to support making snapshots. So as LVM is not allowed to make snapshots, you will get an error message like, well, LVM does not support snapshots, so it doesn't matter if the others could for now. Since this mixed storage pool is a relatively new feature, we can think about make such partial snapshots, but this is just a vague idea right now, so I don't want to make any promises here.
But it is possible to migrate previously LVM resource to LVM thin and remove all LVM replicas and have a new opportunity to make snapshots.
Yes.
I just worry about some corner cases when resource already has snapshots, and we try to create replica on thick pool. Will it not break anything?
I mean, yeah, as I
And
just said, this whole feature is relatively new, so we certainly did not cover every corner case. But yes, if for you, for example, for whatever reason you want to migrate from LVM thin to LVM thick and have already snapshots and try to restore that, that might cause issues, yes.
okay, and what will happen if I'll create snapshot on a resource located in LVM thin and ZFS on both types of this LVM, these thin pools?
Since both LVM thin and ZFS can make snapshots on their own, you will have different snapshots on the both storage pools, but it will work. LINSTOR will happily create snapshots on the one side, ZFS snapshots on the other side, LVM snapshots. That should not be a problem.
Got it. Thank you.
Are there any other questions? All right. Thanks for joining us for the LINBIT community meeting. If you have any questions after the fact, feel free to post your questions in the YouTube comments, or you can contact the LINBIT experts directly at linbit.com. Also, be sure to like and subscribe to the LINBIT YouTube channel to learn more about us and our software. Thanks again for watching, and we'll see you in just a LINBIT.